So we're going to start today with a little activity. If you could just find a coin, and if you wish to do this now for yourself, and then later on maybe get other family members to join in, and they're going to go through this process too, and then just keep track of all the outcomes that land heads up. So for the first time you're going to do this, you're just going to flip a coin 10 times and just record how many times out of those 10 flips it landed heads up. So keep track of that. Call this your first trial. And then you want to do this again. You're going to flip the coin 10 more times and then record the number of times it lands heads up. So this will give you a total of obviously 20 times, but then I want you to have a couple more family members to do this. Again, have them first just do this out of 10 and then do another 10, so then they'll get a total out of 20 as well. And then just record how many times it lands heads up. I'll conclude this little activity tomorrow once you have all of your outcomes recorded. I'm going to create a little Excel spreadsheet and share that with you, or Google Sheet, and share that with you for you to record everything. So just keep track of each trial, each person, and then how many times the coin landed heads up. All right, as we proceed, we're now going to start section 4.2. This is where we start to talk about the addition rules of probability. Now, we pretty much have already looked at this, we just didn't define it this way. And what we're really going to focus on are looking at events that we consider to be mutually exclusive or not mutually exclusive. So when events are described as mutually exclusive, they cannot occur at the same time or they have no outcomes in common. For example, if you imagine getting a card, which card you cannot get all on one. So if you draw one card from a deck, and I'm asking for the probability of getting a 4 or a 6, there is no one card that has a 4 and a 6 on it. So in this case, getting a 4 or a 6 from pulling one card from a deck would be considered mutually exclusive. They cannot happen at the same time. Everything else, that if you could look at this as an event that would occur at the same time and that they had some outcomes in common, we would consider that to be not mutually exclusive. So if I asked you for the probability of getting a 4 or a diamond, there is a card that shares these outcomes, and that's just the 4 of diamonds. All right, so in this little example, I just want you to determine which events are mutually exclusive. Now, you could just write ME next to it. I don't want you to say a yes or a no. I want you to say mutually exclusive or not mutually exclusive. And again, this is just when a single card is drawn from a deck. So pause the video to write this out and see what you're coming up with. All right, so if you need more time, just pause the video again. So for A, getting a 7 and getting a jack, is there a card that has a 7 and a jack on the same, would that be on the same card? No, so these would be mutually exclusive. So we could just put ME, mutually exclusive. For B, getting a club and getting a king, well, is it possible to get a card that's the king of clubs? Yes, so this would be not mutually exclusive. C, getting a face card and getting an ace. Aces do not have any faces on them. The face cards are the jack, queen, king, so you could either get a jack, queen, or a king, or you can get an ace. You can't get one card that has both, so this would be mutually exclusive. And then D, getting a face card and getting a spade, that would not be mutually exclusive, that they do have that common outcome, because you can get a face card, you can get a jack of spades, you can get a queen of spades, or you can get the king of spades, so this would be not mutually exclusive. So mutually exclusive is when it's unique. They have no outcomes in common. You have one card separate from another. They cannot be on the same card, at least in this case with drawing a card from a deck of cards. There's going to be other examples that we're going to be looking at this identification as well. All right, so our first addition rule is when two events, A and B, are mutually exclusive, the probability that A or B will occur is, so anytime we see the probability of A or B, the word or is important here. This is the probability of getting A or getting B. But in this case, because they're mutually exclusive, there isn't the probability of getting both. So here we simply add the two probabilities together. So let's take a look at this example. Go ahead and pause the video to copy this down. All right, so in this example, tells us a city has 9 coffee shops. 3 are Starbucks, 2 are Caribou Coffees, and 4 Crazy Mocha Coffees. If a person selects one shop at random to buy a cup of coffee, find the probability that it is either Starbucks or Crazy Mocha Coffees. So we'll just write this out here. Probability of Starbucks, we'll just use an S, or we'll do Crazy. We'll do Crazy MC. All right, so because it's the word or, all we're simply going to do is add the probabilities together because these are mutually exclusive. You can't go to Starbucks and it's not asking for an and Crazy Mocha. It's asking for one or the other, so there's no outcomes in common. So for Starbucks, we've got 3. If we added these up, notice we're seeing the 9 here. So we have 3 out of the 9 that are Starbucks plus 4 out of the 9 that are Crazy Mocha Coffees. So we simply would just add those together and say we have a 7 out of 9 chance that if someone chose a coffee shop at random, that it's either going to be Starbucks or Crazy Mocha Coffee. Which is what we were doing before. Like I said, we just didn't identify this as a mutually exclusive event. All right, so our second addition rule is if A and B are not mutually exclusive, that means we're counting like the cards, we're counting some cards twice, so we have to subtract the ones we've already counted. So this is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So if we counted like the 4s and diamonds, so we counted all the 4s, we counted all the diamonds, but we counted the 4 of diamonds twice, so we would just have to subtract the card that was a 4 and a diamond. And we have done that before in section 4.1. All right, so instead of always looking at a spinner or cards or dice, we might be given a little table here. So please go ahead and copy this down. Selecting a medical staff person. So we could have nurses or physicians. They could be male or female. So we just have our totals here. Now what we're going to do is identify the probability I'm asking you for here as mutually exclusive or not mutually exclusive, and then we'll know what kind of formula to use. All right, so the probability that we choose a staff member at random and they're nurse or male. So we would call this would be like A or B. So the nurse is going to be the A and then the male is going to be B. So is there a chance that we can get a male nurse? Of course. So we do have male nurses here. So this would be not mutually exclusive. So in this case, we would want the probability of A plus the probability of B minus the probability of A and B. All right, so we're just going to add the probability of A, meaning the probability of getting a nurse. So we have a total of, if we're looking this way for nurses, we have a total of 8 nurses. We have a total of 13 staff members altogether. Now we could write these as individual fractions, or you can just add and subtract all in the numerator and put it all over 13. I prefer just to show individually here. plus the probability of male, getting a male staff member. So if we look at the males, we have 3. So we'd have plus 3 out of 13. Then we would subtract how many male nurses there are, and that's just 1. Because we already counted the male nurse. We counted them twice, so we have to subtract 1 of the extra times we counted. So we're going to get 10/13 here. All right, the second probability is of getting a nurse or a physician. Now, just based off of this table, we're looking at the probability of A or B still. But in this case, are there any nurses that are also physicians? No, you're either going to be a nurse or a physician. And it's just off of this table. A person cannot be both. So for this is going to be mutually exclusive. So we're just looking for the probability of A plus the probability of B. We do not have to subtract any because from this table, there are no nurses that are also for physicians. All right, so the probability of getting a nurse, again, is going to be 8 out of the 13. And the probability of getting a physician is going to be 5 out of the 13, which gives us 13 out of 13, or 1. And does that make sense? Because the staff is made up of only nurses and physicians, so the probability of getting one or the other is going to be 100%. But again, we're just trying to use the formula here, the addition rule, to help us out. There was no need to subtract in this case. All right, so the probability rules can be extended to 3 or more events as well, and it just goes along with just adding the individual probabilities. And again, I'm just showing you this for mutually exclusive events. The probability of getting A or B or C is just the sum of their individual probabilities. All right, so tomorrow I'm going to go over all of the answers to section 4.1 worksheet. For today, I want you to check them and let me know if you have any questions. Like I said, tomorrow I will, in the video, I'm going to go over each answer. And in class as well, I wanted to show those answers and take questions. Once you have checked and corrected that worksheet, go ahead and start worksheet 4.2, and I'm giving everyone tomorrow to work on it as well. Let me know if you guys have any questions.